All right, so here we have a limit with a square root in it. So we have to be careful because, right, we can't take the square root of a negative number. So let's take a look at what happens as we approach 2 from either the left or the right. Okay. Now, if I put in 1.9, now that's a little bit less than 2, but 1.9 minus 2 is a negative. So this does not exist, right? I can't do it without imaginary numbers, right? So there's no real number. The same way with all of these when z is less than 2, right? I'll end up with the square root of a negative number. So these don't exist, right? Now, if I put in something a little bit bigger than 2, then I can do it, right? Because something bigger than 2 minus 2 is going to be positive. So when I put in 2.001, now I should probably start over here, right? Because I'm approaching 2 from the right hand side. So let's just start at 2.1. All right. So when I put in 2.1, I'm going to get 1.31, whoops, 3162. Okay. That's, oh goodness. All right. I don't know why that does that. All right. And now if I put in 2.01, I just get 1.1. Okay. And I put in 2.001 and I get 1.03 16. Okay. So it looks like the square root part is approaching 0 and then we're adding 1 to it. So it would make sense that we're approaching 1, right? Which is what we get by direct substitution. You could just put in 2, and you might be tempted to say that the limit as z approaches 2 is just going to be 1, right? Because if I do direct substitution, it works, right? But no, because you have to be able to approach 2 from both the left and the right hand side. So the limit as z approaches 2 of this function square root of z minus 2 plus 1, right? This limit does not exist. DNE. Okay? Right? Because the square root is undefined for negative numbers. Okay? So we can approach from the right, but we can't approach from the left, so that means that the limit doesn't exist.